We are going to put your skills to the test, and this is a real test, so you want to put your thinking cap on. All right, I'm going to give you an argument and I want you to evaluate it for validity, but I want you to do so from the Aristotelian standpoint only. Don't mess around with Boolean, modern square of opposition. We're looking just at using the traditional square of opposition and the Aristotelian standpoint. And what you're going to determine is this: according to the traditional square of opposition, is it impossible for the conclusion of this argument to be false when we assume the premise statement is true? If that's the case, you're going to identify the rule or operation that proves that so. But if it is possible for the conclusion to be false when the premises are true, you're going to identify the fallacy that proves that judgment so. All right, so this is a really good opportunity to do a self-assessment to see how well you're grasping the skills of this very difficult thought primer. So I really want you to pause your video, do your work, and when you're ready to check it, go ahead and restart your video. Okay, so here's your argument, and there's the traditional square. Pause your video. All right, boy, I hope you paused. This is a really good one to practice with. All right, did you say that this argument is valid by subalternation? If so, you're wrong. And it'll be way easier for me to show you why you're wrong if I symbolize the argument. This is a super important practice to develop, habit to get into. Always reduce your arguments down to single letters. It makes it so much easier to see what all is going on. Because in an argument that's written like this, it's kind of all jumbled up and really hard to see what all is happening here. But when I symbolize it, I see that my premise statement is all S or L, and my conclusion statement is some L or S. And the rule of subalternation does say that if we assume an A statement is true, like our premise statement here, that truth value trickles down and makes the corresponding I statement also true. However, those A and I statements have to be corresponding. In other words, their subject and predicate terms have to be identical, and here I can see they're not. In the premise, my subject term is S, and that's not the subject term of the conclusion. The subject term of the conclusion is L. And you can see the same thing going on with the predicate terms here. So to say that this argument is valid by subalternation doesn't get us there. Instead, what we're going to have to do is we're going to have to think if there's a creative way that we can apply multiple operations to this premise statement to generate this conclusion statement with a known truth value. Okay, so we might do something like start with subalternation. If we subalternate our premise statement all S or L, we're going to get the statement some S or L. And that's also going to be true when we assume all S are true. So now the question is there anything that we can do to this statement some S or L to produce this statement some L or S? And the answer is yeah, we'll just convert it. So if we convert some S or L, we'll get some L or S. And that statement will also be true because we're allowed to convert I statements. And that's exactly what the conclusion statement says. So we might say, oh my gosh, this argument, it's not valid by subalternation, it's valid by subalternation and conversion. And it's really important that we identify those rules in that order. Because if we had begun with conversion and converted all S or L to generate the statement all L or S and then subalternated that, when we did our step of conversion, we would have created a statement with an unknown truth value because we're not allowed to convert A statements. When we do that, the truth value becomes undetermined and it never comes back at that point. But if we subalternate first, we keep track of that truth value. Okay? So this argument is conditionally valid by subalternation and conversion. But the condition has to be met in order for this argument to be valid from the Aristotelian standpoint. And so the question is, do slithers exist? Because the requirement for validity from an Aristotelian standpoint is that the subject term of the premise be an existing thing. Do slithers exist? No, I made it up. So at least I don't think they exist. So this argument actually is invalid because it commits an existential fallacy, even though it was conditionally valid by subalternation and conversion, ultimately invalid by existential fallacy. Now what you see going on here is this. Rules and operations can be used in combination with one another, and things can get super tricky super quickly. So what you're going to want to do is you're going to want to make sure you are always reducing your arguments down to single letters so that you can track really clearly what's going on in those arguments, because we can apply multiple operations and rules to create statements that don't look much like anything like their originals, and it can make it really hard to figure out what all's going on. So let's say I had the statement all answer insects, and I assume that statement is true. I'm going to reduce that down to individual letters, all A or I. If all A or I is true, then by subalternation, some A or I would also be true. And if some A or I is true, then by obversion, some A or not non-I would be true. And if some A or not non-I is true, then some I or not non-A would be true by contraposition. And if that's true by contraposition, then by contradiction, all I or non-A would be false. And if that's false, no I or A would be false by obversion. Okay, so we can just keep running around this square, creating new statements, going from true to false to true. And as long as we're applying those operations in ways that we're allowed, we're always going to know what the truth value of our new statements are. Okay, so last thing. I want you to take a look at this argument, and I want you to analyze it for validity. And I'm just going to give you a hint. There's more than one rule or operation at work here. So you're going to want to break this thing down into individual letters, and then see if you can figure out what rules are being, and operations are being used in combination to create this argument, and whether or not it's valid. Make sure you get the ordering of those rules correct. Okay, so pause your video, and then when you're ready to check your work, we'll rock and roll. All right, let's rock and roll. All right, so if we break this down into terms, I chose D and C. I'm betting you did too. All D are C, no non-C are D. Okay, how are we going to work with this? Okay, so the first thing we do is we got to invert that premise statement. All D are C, inverted becomes no D are non-C. Then we convert that guy, and we get no non-C or D, and that is our conclusion. And it's unconditionally valid, okay? So this one's unconditionally valid by obversion and conversion in that order, and that means it's valid from both the Boolean and Aristotelian standpoints, all right? Good job.